Hello, my name is Rajita Iyer. Welcome to my presentation of my final project for Info 614. In this presentation, I'm going to talk about the problem of the global digital divide in rural areas in developing countries, and outline a proposed solution for network connectivity. Part 1 introduces the global digital divide. You can see here a definition of the digital divide. The actual statistics are hard to investigate and sources differ on the numbers, but in general we can say that industrialized countries contain the majority of internet users, but a minority of the world's population. Or at the very least, developed countries have much higher percentages of connected population versus developing countries. Developing countries lack the capital to solve the problem at sufficient scale and speed, and rural areas are the most affected, particularly as they lack access to medical facilities. These are the characteristics of rural areas in need. They are extremely poor, they're often remotely located, they have low population density, they lack in IT-skilled professionals, they lack in infrastructure with telecommunications, power lines, roadways, and other such infrastructure, and they are generally non-English speaking, and sometimes have extreme weather conditions. Therefore, any solution to bridge the digital divide should ideally meet these requirements. It should be low cost, remotely diagnosable, be long distance, reliable, low energy, require minimal installation, allow for intranet or internet-based solutions, weatherproofing, and have high bandwidth for telemedicine. This is a cleaner version of the ideal requirements. This section outlines a model for a solution using Wi-Fi for long distances technology, an adapted form of the 802.11 standard, the common Wi-Fi we use every day. The proposed model will establish end-to-end links between network nodes placed anywhere between 10 to 100 miles apart. Using commercially available off-the-shelf wireless hardware, customized with open-source firmware or software, the Wi-Fi standard can be optimized for long distances. It's achieved 3 Mbps speeds at working deployments. The nodes operate independently off of solar panels and rechargeable batteries, or an established power grid. This model can be used to establish an intranet, connecting many rural villages with a service location such as a hospital, and can be connected to the internet as well. WILD is low cost because it uses an unlicensed frequency, does not need industrial hardware, can work at long distances, is well established, and therefore well explored. It does not require much infrastructure, can be used for both an intranet or internet-based solution, can be protected against the weather, though being above ground still poses a problem, and can achieve the necessary bandwidth for telemedicine. So what is needed for implementation? You can see here a list of equipment. Links require line of sight, so in-deployment nodes may be established on hills or built with towers. Some common issues. Wi-Fi was established for short distances, so an increase in transmission power through the radios and receiver sensitivity through high-gain antenna is needed. Wi-Fi is normally used with the random access protocol, so when a channel is busy, the transmitter backs off for a random amount of time. However, the system relies on acknowledgments from the receiver to verify packets have arrived, but with longer distances come longer propagation delays, which can result in constant acknowledgement timeouts, flooding the link with unneeded duplicate frames and keeping other nodes from transmitting. A switch to a hybrid time division and code division multiple access protocol allows for nodes to transmit and receive in time slots appropriate for the propagation delays caused by longer distances. This keeps the link from flooding with duplicate frames from ACK timeouts. TDMA alone creates delay issues which affect video transmission because throughput is reduced and the link remains idle if other nodes need to take a turn but have nothing to transmit. CDMA solves this issue by allowing nodes to use maximum available throughput, transmitting at the same time and reducing delay. Some final thoughts. Though this presentation does not address everything in the project, there are still unresolved issues. For example, remote diagnosis is not addressed and remains an issue. Though weatherproofing is easily done, it cannot be completely accounted for, and if a node goes down, the system is not self-healing. There is also a lack of data on this technology and its proposed deployment, but it is clear that there is a need for some custom hardware or firmware. Finally, it should be said that this model is based on new evolving technology that is yet to grow. Though it has been deployed in the field, there are many known issues that still have to be addressed. It is workable, but it is not the only solution and must be adapted for whatever environment in which it is to be deployed.